Hello everyone, this is Ginny Kam from GuruMe. So for today's class in chemistry, we'll talk about energetics and thermochemistry. So I don't like the boring stories of energetics, so I will start with energy. So we know what energy is, but we really can't define it. So scientifically, definition is really important. So before we go into the boring definition, we'll talk about light stories on energy. What energies do you know? Maybe thermal energy. So that's heat energy. Or, yes, motion energy. Or gravitational energy. Or we say potential energy. So the simplest form of energy, let's think about it. Well, if we go to the theme park, we've ridden a roller coaster, right? So if we start roller coaster here, hey, and then go up, we go up by something called electricity, which is electrical energy. And then if we drop down, does that require an electrical energy? No, we have the gravitational energy or potential energy that is driven by gravity. And then it transferred to motion energy that drops your cart down. So we see energies are retained and energies can be converted into one form to the another. Let's say in this case, electrical energy has been converted into potential to motion. But here's the thing. When you are, let's say, at the top of the roller coaster, can you identify your potential energy? Can you say, oh, I have 53 joules here? Not really, right? Same. If you go up to the building, you have the potential energy to drop down, but you can't really identify how many energies you have, right? So chemists thought, well, we know there are lots of forces, energy, but it seems like motion energy is hard to define, and gravitational or potential energy is hard to define. But we can define heat by how? Yes, thermometer. So that's the invention of thermodynamics. So let's talk about thermodynamics. Before we talk about it, exothermic and endothermic reaction is the introduction on this page. So we know we talked about the category of the energy, but here we will learn the definition of energy. It's not really important in chemistry, so this is just an introduction, so you don't have to really memorize the definition of energy. But it's a good intro, so we'll start with that. Energy is defined as the ability to work. That is, move a force through a distance, and it is measured in joules. Just like how distance is measured in meter or feet or inch. So energy is like that. You move a huge box to the left side. So it's natural to think that there would be a difference in energy to move a huge and heavy box and small and light box, right? But actually, that's not all. Depending on how long you drag the box, it changes the energy. For example, if you move this huge box in, let's say, a centimeter, then, well, yeah, it could have cost a lot of energy, but it might be the same energy as you move the small light box into, let's say, 1,000 kilometers, right? So in order to compare the energy, you need both force and distance. So the force has the unit of Newton, and distance is measured in meter. So if you force 1 Newton of the force on the box, and then if you moved, let's say 1 meter, it will have 1 Newton times 1 meter, which is 1 joule of energy. Are we clear about that? So we move on to talk about thermodynamics. In a chemical reaction, energy is required to break the bonds, or energy is given out when new bonds are formed in the products. The most important type of energy in chemistry is, as we talked about, heat. If the bonds in the products are stronger than the bonds in the reactants, then the reaction is said to be exothermic. So think about it. So you are single and sad and lonely, and think about the ideal partner in your life, love of your life comes in front of you. Then you will be bond with him, let's say being a couple or get married, and get more happy. Double happy, bonded. So from your unstable single state to your couple happy marriage life, you will put out the energy of unstability. Okay, so that's the gist of exothermic. You were an unstable person to happy married person, and energy is given out in the process. So in exothermic process, the energy that is given out would be heat that is given out to the surroundings. So examples of exothermic bond in the reactant in process include combustion and neutralization. We know what combustion is. Combustion is when something is burned, right? So when things are burned, it releases heat, right? So that's why you feel warm beside fire. So in combustion, as the material is combusted, the energy is given out as a heat, and that's why it feels warm. And another example would be neutralization. I don't know whether many of you heard about neutralization, but neutralization is the process of acid and base getting reaction. So we know acid are acidic and base are basic, and if both of them meets, they will get neutralized in, let's say, neutral. So for example, the acid is HCl, the hydrochloric acid. I don't know, many of you have heard of it. It's a most famous acid example. And for base, it will be sodium hydroxide. So when they meet together, they will go through a chemical reaction and form H2O, which is water, and sodium chloride. Have you heard of sodium chloride? Yes, that's the table salt. So actually by mixing acid and base, you will make salty water. And in the process, they will release heat. So they become more stable. How about endothermic reaction? in endothermic reaction, reaction heat is absorbed from the surrounding because the bonds in the reactants are stronger than the bonds in the products. So, for example, in this example here, reactants would get stronger or heat absorbed from the surrounding to become more unstable products. So let's say I was a happy married person, and then another person comes in and then talk about bad things about my love in life. So there is this energy required breaking bonds between me and my love. And then if the energy is strong enough to convince me that the love of my life was not actually the love of my life, then I'll actually break up with my love and then become a more sad and unhappy single back to the life. So that's the endothermic reaction. So heat is absorbed, so energy is absorbed to become more unstable products. And in endothermic reaction, because you see the therm, you will absorb the energy in the heat perspective. So we talked about heat and how energy is given out or given in, absorbed in, and they can be measured in something called enthalpy. And the definition of enthalpy we have to memorize this time: internal energy stored in the reactants. So mind the term internal. So does that mean you can actually figure out the absolute enthalpy? If you possess internal energy inside, can you measure it? No. What you can measure is if there is a change in the enthalpy, you can measure the change of the enthalpy. For example, the absolute value of enthalpy of the reactants cannot be known because it's internal. However, you can figure out the difference. So we know how much I become stable after I get married. But I can't really define how unhappy or happy I am at this moment. So this moment I can't know. And how much I become more stable and happy at this moment either. What we can know is just the difference. And the difference of the enthalpy can be defined as enthalpy of the products minus enthalpy of the reactants. And we put the delta sign in front. Are you familiar with the delta sign? Delta means change in. Okay, so we've seen in math when we talk about gradient, we know gradient is the change in x and change in y, right? And then in symbols, we write delta y over delta x. Just like delta represented change in math, delta in chemistry also represent change. So, by convention, delta H is a negative value for exothermic reaction and a positive value for endothermic reaction. Why is that? So think about it. I don't know the absolute value in real enthalpy change, but let's say it is 100. And let's say how the absolute value of product of enthalpy is 30. Then because we are taking out reactants from products, 30 minus 100, it would give you negative 70, which is negative value. That's why exothermic value enthalpy will have negative enthalpy. However, it's the opposite for the endothermic reaction. That, let's say reactants were 30, enthalpy and 100. And in this case, product is 100 and reactants is 30, which becomes positive 70. So positive is for enthalpy changes in endothermic reaction. Are we cool about that? So we move on. It is normally measured under standard condition of 100 kilopascal pressure at a temperature of 20 to 98 Kelvin. So if for those of you who are not familiar with pressure unit or Kelvin unit, I'll talk about it. So we know, like, if you become a scientist, you will carry out the experiment under a normal condition, right? Standard condition. That is, in our pressure, it's called 1 atmosphere, 1 atmospheric pressure. And a mathematician, Pascal, who is a mathematician, figured out that 1 atmospheric pressure is an equivalent to 10 to the power of 5 Pascal pressure. And because kilo is 10 to the power of 3, of course, it becomes 10 to the power of 2 kilopascal. Okay, so if you could jot down the notes under the 100 kilopascal, that would be great. And temperature 298 Kelvin, we know how Celsius and Kelvin can be converted, right? What we do is Celsius plus 273 will become Kelvin. So if we go inverse of that, 298 Kelvin is equal to 25 Celsius. So what normal scientists decided is that normally the experiment could be carried out 25 degrees. So that's why the standard temperature becomes 298 Kelvin. So the standard enthalpy change of the reaction under 100 kilopascal and 298 Kelvin, that is called delta H hat. So this hat looks something like this. So for any of the experiment that is carried out under the standard environment, you will put delta the hat here. Cool. So moving on to the temperature and heat, it is important to be able to distinguish between heat and temperature, as the terms are often used loosely. But in chemistry, we have to define and correctly use the term. Heat is a measure of total energy in a given amount of substance, and therefore depends on amount of substance present, while temperature is a measure of hotness of a substance. It represents the average kinetic energy of the substance, but it is independent of the amount of substance present. So for example, let's say there are 2 beakers present, and the first beaker would just have 50 centimeter cube volume of water, while the second one will have 100 centimeter cube volume of water. Both of them, the reading of the thermometer read the same for their temperature. However, is it okay to say their heat or their energy contained are the same? Well, not really. Or if you are confused, let's go for extreme. Let's say 1 centimeter cube, that's just a drop of water. Drop of water 50 Celsius and 100 centimeter cube of the water in 50 degree, they would have different energy, right? Well, while the drop of water, 50 degree drop of water, you wouldn't feel really warm or hot if it touched your skin, you will get burnt if 50 degree of water with 100 centimeter cube is poured on you, right? So there is a difference between heat and temperature. So how can we measure heat? By measuring temperature, right? So there is something called calorimeter or calorimetry. So enthalpy change of the reaction can be measured experimentally by using calorimetry. So we talked about, we know what calorie is, right? We've seen it in a product and we see nutrition information of the product that says 297 kilocalorie or calorie. So the calorimeter measures the enthalpy change, and let's see how the calorimeter works. In a simple calorimeter, all the heat evolved in an exothermic reaction is used to raise temperature of a known mass of water. So this exothermic reaction is most of the time combustion or neutralization. Okay, so this is the simplest calorimeter. For example, you will have polystyrene cup that is styrofoam, and you put the reaction mixture inside and figure out the temperature with thermometer and put the lid on. The reason why we put lid and polystyrene cup is in order to avoid the heat loss, in order to measure the temperature as correctly as possible. So we can draw the graph with it, and in order to study graphs, we will see in the real class. I'll see you a bit soon.